Particles can be classified as bosons or fermions. A defining characteristic of a boson is its ability to pile into a single quantum state with other bosons. Fermions are not allowed to do this. One broad impact of fermionic antisocial behavior is that it allows for carbon-based life forms, like us, to exist. If the universe were solely made from bosons, life would certainly not look like it does. Recently, JQI theorists have proposed an elegant method for achieving transmutation, that is, making bosons act like fermions. This transmutation is an example of emergent behavior, specifically what's known as quasi-particle excitations, one of the concepts that make condensed matter systems so interesting. Particles by themselves have mostly well-defined characteristics, but en masse, can work together such that completely distinctive, even exotic phenomena appear. Typically, collective behaviors are difficult to study because the large numbers of real particles and all of their interactions are computationally challenging and in many cases prohibitive. JQI fellow Viktor Galitsky explains, the whole idea of emergent excitations is that the quasi-particles are fundamentally different from the actual individual particles. But this actually doesn't happen that often. In this case, it turns out that the boson to fermion transmutation leads to an interesting phase of matter. Galitsky continues, here, the bosons don't condense, they instead form a state without long-range order. This is an example of a long-sought-after state of matter called a Bose liquid. Here, the central technique also involves taking an optical lattice made from laser light and shaking it back and forth. An atom optical lattice system, analogous to a crystal, has a periodic structure. Laser beams crisscross to form standing waves of light that resemble an egg carton. Atoms interact with the light such that they are drawn to the valleys of the egg carton. Like a true solid, this system has an accompanying band structure, which describes the allowed energies that atoms within the lattice can take on.